Hi all, this is Mr. Yeager with looking at physical science with our first section on motion. We're going to look at basically how do you know motion is occurring, as it says at the top, describing motion, and then looking a little bit at speed and velocity, and then how we can graph motion a little bit. So this one will be a little bit longer. But there's a lot of pictures and things like that we're going to try to illustrate with a lot of examples and things like that. So here we go. So the thing is, how do you know an object is moving? You know, that's basically the initial question that we have to ask. How do you know an object is moving? And, you know, most people just say it's because the object is in one place and then it is in another place. That's correct. If an object does move from one spot to another spot, that is motion. We know the object's moved. If we see the object is staying in the same position, we know it's not moving. So the first thing we kind of have to point out is this idea of what's called a reference point, or I've kind of added in there, it's your point of view. So a reference point, as this says, is basically, it tells you where the position of the object is. Where is your object, okay, in relation to you, all right? And in the classroom, usually I can use the example where I walk to the back of the room. Some people think I'm walking away. Some people think I'm walking toward them. That's just based on, again, this reference point. Let me change my color here. Your reference point there. That's brighter, right? Okay? And so, again, it's just based on how you are perceiving that motion. All right? One person that thinks they're moving to the right, if they're looking straight at them, somebody else might be going, you're moving to the left. Again, that's just the way we look at it, and that's where I have my example there. You know, we have each a different point of view within a classroom, okay? So I have this picture here, basically of a big soccer stadium, all right? The idea here is, depending on where you're sitting, you're going to have a different point of view of that particular motion, okay? You know, people sitting on this side, look at that, of course, move forward. People sitting on this side would perceive people running to the right down the field that way, while on this side, people are running to the left. If you're sitting on the other side, people running this particular direction would be to the left, this particular position would be to the right. You know, again, if the person's running this direction, this crowd would think it's running toward him. This crowd would think they're running away from them. So, again, that's the idea of reference points. It's your point of view of what's happening with that object in motion. Okay? So that's what we have here. Motion, as most people point out, is when you are changing position relative to a reference point. Okay? Motion is a change in position. All right? Is what's going on there. So it depends on where you are moving in relation to, again, this reference point. So our first kind of measurement of motion is distance. And again, I feel like most people already know this. It's just simply how far you move. How far you move. It is measured in meters in physical science, which has the symbol M. Abbreviation M after the number. Okay? So how far an object moves. Okay? That's different from what we're going to call displacement. So here's already like the little tricky thing with some motion stuff, is we have two terms that measure sort of the same thing, but have different ways that we're going to look at it. I mean, it's basically we add in an extra piece when we add the idea of displacement. So distance is simply how far you go. Distance is just you keep on adding it up. Displacement, on the other hand, is the distance and direction that you go. The distance and direction from your starting point. Again, from the starting point. All right? Sorry, that's going to go away. Okay? So there's, I try to define this a couple other ways. Another way to think about displacement is just how far away from where you start. How far away from where you start. That is your displacement, is what we're looking at there. So, distance on the other hand, I'll write it one more time, is how far you go total. So if I use this diagram over here, what we would say is, if I'm looking at the distance, the person has run 50 meters up and then 30 meters back. So for distance, I add that all up. I don't care which way I go, I just keep on adding up the numbers. So this would be a total of 80 meters. Okay, that would be your distance. Your displacement, though, is only caring about where you start and where you end. That's the only thing that displacement cares about. It doesn't care how you got there. It doesn't care about all the different motions you do. It cares only about the beginning and the end. It doesn't care about anything else in between. And if I look from the beginning to the end, the person is only 20 meters away. They're only 20 meters from where they started. So this would be your displacement, and then we would add a direction to it. We would say you've gone 20 meters north. Okay? As it says underneath of it, 20 meters north. It's always measured from start to end. You're 20 meters from where you started, north of where you started. It's not from where you end going back. That's usually a common mistake. Some people will measure and say, you're 20 meters south. No, 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 no. It's where you are right now. You're 20 meters north away from where you start. So again, distance is how far you go total. Displacement is simply start to end and which way are you from the starting point. So in my PowerPoint, I generally then show some videos and things like that. You know, I show a 400-meter race, okay? The thing is, we could go, okay, 400-meter race is one time around the track. That's 400 meters, okay? One entire time around track. So if I say, what's the distance that you traveled? What distance did you travel? You'd say 400 meters, because that distance just cares about how far you go. But what about your displacement? Displacement is where you start to where you end. Well, if I go 400 meters, I start right here, and I go around, and I'm back at the beginning again. So how far are you from the beginning? 0 meters. That always makes people freaked out initially, because they're like, wait, what? You moved. How can you say you haven't moved anywhere? Displacement only cares about beginning to end. It doesn't matter about beginning to end. Only those two spots. How far away is the beginning point and the end point? They're at the exact same point, so you've gone 0. I'm going to tell you, 0 is a very common, popular answer in physical science for the physics section. Okay? It is very common in physics for us to just want to know that, hey, the answer is 0. 0 meters, 0 energy, 0, momentum, all that type of stuff. We will see that 0 is very common. It scares people because they're like, oh, I don't like that 0 is the answer. 0 is the answer. I always say it's a good answer, not a good grade. It's a good answer, okay? So 0 meters. For the 100-meter race, I'm going to erase this, okay? They start obviously from one point and go down straight in a line. In a 100-meter race, we would say the distance is 100 meters that you travel, because again, that doesn't matter. Distance doesn't care about what you do, it just cares about where you've gone total. Displacement, I'm here, and now I'm 100 meters away. Guess what? The displacement is 100 meters. We'd say 100 meters north, right? Or something like that. The 100 meters this way, all right? So that's what happens there. The last one that I show is this dog that's constantly running back and forth across a couch. So it's like going this way, and then going this way, and then going this way, and then going back this way, and then this way. What you have to do here is, let's say this is just 1 meter. We'll make life easy. 1 meter, 1 meter, 1 meter, 1 meter, 1 meter. The distance, we'd add all those up. 1, 2, 3, 4, 5. So 5 meters is the total distance the dog has traveled. But what's the displacement? Well, I have to figure out. He's gone 1 meter away, then 1 meter back. So he's currently 0 right here. 1 meter away, 1 meter back. 0 right there. Then 1 meter away. So we'd say 1 meter to the right is our displacement. All right? That's where he finished up at the very end, from the beginning to the end. We'd have to go technically all the way back to the beginning to the end. He is 1 meter away from that starting point of where he was. Okay? So distance, just add it up, add it up, add it up. Displacement, look carefully. Beginning, end, who cares what happens in between? Figure out the difference between those two. All right, this leads us then to speed. Okay? Speed is the distance an object travels per unit of time. Okay? And as I say, in other words, just how fast it's moving. Okay, how fast is that? So now we're talking about how quickly is it changing its distance. How quickly it is moving from one place to another place. All right, so it's we sometimes say it's the rate we change our distance. The rate we change, I'm going to say our position. Okay? So that would be another definition for speed, the rate that we change our position. Okay? We calculate it by doing distance divided by time. I mean, that's it. It's just how far do you go total divided by the total time. Distance divided by time, you can see the units are in meters per second. Meters per second. So distance divided by time. Okay? So again, the unit for speed can be a lot of other things. We're more, obviously, in our everyday use, we're used to miles per hour. Okay? But it's, again, it has to just be a distance unit divided by a time unit. We will primarily use meters per second in physical science. Meters per second. Okay? But again, any speed can be calculated by doing distance over time. All right? We then kind of get some other names for this. So, I mean, kind of just pay attention as we're going through this. There's some other kind of more specific names. For average speed, this is the total distance traveled by the total time traveled. Now, you might be going, what's different about average speed and regular speed? For average speed, a lot of times what we're looking at is we talk about an entire trip that you're going on. In this particular problem, it's basically the exact same thing, okay? Don't get that confused between average speed and regular speed. It's still distance over time. We just get more specific, saying total distance over total time. The difference that we run into sometimes is we can be like, you go 10 meters in 5 seconds, then you go 20 meters in 4 seconds, and then you go 10 meters in 5 seconds, okay? I could technically sit there and be like, what's my speed right here? 10 divided by 5 is 2 meters per second. What's my speed right here? 20 divided by 4 is equal to 5 meters per second, etc. If I want to do the average speed, I add all of these up, I add all of the times up, and I divide them. So this would be 40 divided by 14. Yay, I didn't give myself something easy. This would basically be, it's going to be slightly less than 3. So I'm going to say 2.8. I mean, it's something like that. It's whatever 12 over 14 is. I can't do that in my head. So that would basically be your speed, your average speed. It is kind of averaging out the different speeds that you have up here, but you don't want to do it like a mathematical average. That's usually the biggest mistake, is people try to add the speeds up and divide it. That's not true. It's a weighted average, and we're not going to mess with that. Okay. There's also what we call an instantaneous speed. Again, this is more just terminology. This is what you would see on your speedometer if you drive a car. All right, and it's your speed at that particular moment. Okay, it's your speed at that moment in time. Again, the idea here would be, you're driving to school, maybe you have an average speed of only about, I'm going to say 20 miles an hour from your trip home to school is your average speed. But is that saying then that you're going only 20 miles an hour the entire time? I hope not, if you're like on certain roads where it's 50 miles an hour. You're probably maybe going 50 miles an hour for a short period of time, but then you're going slower, you're stopped, you're at red lights and things like that. So your instantaneous speed would be, police catch you, what do? Look down and you go, oh, my speed is 65 at this time. Unfortunately, you can't argue with the police and go, well, my average speed my entire time has been only 15, so you can't get mad at me. They won't accept that, sorry. Okay? And then, really no, not last thing, sorry. I lied. We're going to now look at, so that's speed. Just like distance and displacement, we have two terms for this movement, speed and velocity. Speed is more with the distance. We're going to see that velocity is speed and direction. Okay? Velocity is speed and direction. So just like displacement is distance and direction, velocity adds in all what we've already taken care of, the speed, but also which way it's going. It's calculated the same way as speed, distance divided by time. Technically, we would say displacement divided by time. All right? But we would then have to add in the direction as well. We need to now say which way are you going. So that's usually just included in the wording. This question is probably like you traveled 100 miles in 2 hours toward the south. What's your velocity? It would be 50 miles an hour south. Your speed would be 50 miles an hour, but your velocity is all of this together, 50 miles per hour south. So just if it asks about velocity, make sure you add a direction in there as well. Okay? So this comes up with some questions that people do initially struggle with some, of the idea that since velocity has a direction, when you turn, okay, you change, turning changes the velocity. So this is where it's a little tricky for some people. So the idea is this car is going around this track, let's say at a constant, I'm going to use more common terms, 40 miles an hour, more common units I should say, okay? 40 miles an hour. You're going around that track at 40 miles an hour, but it's a circular track. We would say your speed is constant because are we changing this value? No. But the thing is, velocity is speed, which, is that changing? No. And direction. The thing is, as this is pointing out, there's always a different direction you're going if you're going around a circle. So technically, all of these cars shown here, even though it's the same car, but each of these points in time for this car, these are different velocities. All right? And that's important because when we talk about momentum and other kind of physics concepts with this, we have to add in the direction to figure out exactly what will occur with maybe a force or energy, not necessarily energy because energy doesn't care about direction, but with a force involved. Momentum, like I said, cares about direction. So while it might seem kind of silly going, oh my gosh, why am I really worried about the direction? We got to keep it in mind if objects are going opposite ways. We'll have a different type of collision occur. We'll have a different, basically, event occur if this car is going one way versus another way. So we do care about the direction. Okay? So just the big thing to remember, when you turn, your speed can stay constant, but your velocity cannot. It has to change. The last thing I'm going to cover with this particular video is graphing motion. Okay? So when we graph motion, there's only a couple of graphs that you're definitely going to run into in physical science on the EOC. One is a position time graph. Okay? A position time graph or a distance time graph. There's all different names to it, so don't be scared if you're like, oh my gosh, you said it's only position. Position, displacement, and distance on a graph basically all represent the same thing. Okay? But we'd set that up, okay? And what we would then do is we're going to interpret what happens here, okay? We're going to interpret what goes on. And there's a couple things for you to interpret. Sorry, I want to see something real fast. Okay. There's a couple things I want you to basically be able to interpret, all right? What they're going to be asking you on position time graphs more than anything else is, one, is the object moving and which way? That's one question. So what I have to do is, whenever obviously there's a slope, I must be moving. Slopes mean there's motion. Okay? Because the idea is, at 0 seconds, I'm at 0 meters, but at 10 seconds, I'm now at 60 meters. So what has happened? I have moved. I have moved. Okay? When I hit a flat line, though, no matter where it is, a flat line on a graph, no slope, means I'm at rest, which means no motion. Rest is our term for no motion. Because what's happening here? At 10 seconds, I'm at 60 meters. At 11 seconds, I'm at 60 meters. 12, 13, 14, 15. 15 is where I start moving. So 10, 11, 12, 13, 14, and at 15, during this time frame from 10 to 15 seconds, I am at rest. But then what happens at 15 seconds? I start moving back. You know, obviously we could say he moves forward and then back. Why do I know he's moving back? Because I'm going back toward 0. So now I'm moving back towards 0. And then what happens here? I actually, I pass where I start and I keep going. And I actually go to the negative side of the graph. Then I technically briefly stop like instantaneously stop, turn around, and start heading back again. Start heading back towards the center. So, excuse me. The idea is when you obviously have a slope involved, you're changing your position. Pay attention to which way you're moving. I'm moving positive this way, negative this way, and then back toward a positive side that way. Okay? So it also is which way I'm going. The other thing you might be asked is how fast you're going. You can find your speed or velocity by finding the slope. The slope is equal to the speed or velocity. So remember what slope is? Slope is, you know, everybody always says rise over run, but hopefully people know what that means. People sometimes don't know what that means. It's y2 minus y1 over x2 minus x1. So if I want to know my speed for this section, I would say 60 minus 0 over 10 minus 0. 10 seconds, okay? And that is 6 meters per second. All right, if I want my velocity, usually I could just add the sign. I'd say it's positive 6 meters per second, okay? Direction can be told by either a positive or negative sign. Like these represent opposite directions. Okay? So we can find the speed by looking at the slope. Okay? We're not going to go to the other graph just yet, just because we need to know another term, and that's going to be saved for later. So we got a little bit of a review here. Oh, sorry, here's another one. Let's just quickly kind of say what's happening here. From A to B, what's the person doing? Correct. We're at rest. Okay? From B to C, what are we doing? We're moving. Which way are we moving? I mean, you could say, I guess, backwards. You could say negative is backwards, so we are moving backwards. But C to D, now we're at rest again. D to E, we're now moving again backwards, back into the negative section. Then we're at rest. F to G, we're actually moving forward. And then G to E, we're moving forward. I guess the other thing I can quickly mention is the slope also tells you how fast you're going. Okay? The steeper the slope, the faster you are. Okay? The faster you are. Basically, the higher the speed. You increase speed with an increased slope. So we would say that you're moving maybe sort of slowly between B and C. What can you tell me about D and E? I'm moving very fast. This is a very steep slope. This one, I'm moving fast, but not as fast as over at D and E. And then G and H, I actually slow down a little bit from F to G. If I want to find the speed of a particular section, let's maybe find the speed between B and C. I find the slope. So Y2 is 4, 0. B is at 2, 10. So what would be my speed? It would be 0 minus 10 divided by 4 minus 2. Actually, this would be my velocity, because it's going to come out to negative 10 divided by 2, which is negative 5 meters per second. Because it's the negative, that's my velocity. My speed would just be 5. All right? So again, with graphs, slopes represent speed. Steeper the slope, faster you're going. Flat line represents rest. That's about it. Okay? So now we're going to do a couple questions here. What's the difference between distance and displacement? Distance is how far you go. Displacement is how far and in what direction. Okay? Speed, that's basically what we have here. How far you go, distance, and direction. All right? It's blank is the distance an object travels per unit of time. Okay? That's your speed. Okay? That would be the speed. All right? It's not velocity. That's where people get tricked. Velocity is speed and direction. All right? What is instantaneous speed? Instantaneous speed is your speed at a particular point in time. Okay? And that's where we're going to finish for today. All right? Thank you very much.